Hey guys, I have some good news and I have some bad news. Bad news, my voice is kind of not good tonight, so I totally apologize. The good news, we're going to have a little break after this video. Oh my goodness, sorry, my oven is telling me that my tea is ready. We're going to have a little break after this set of notes, and we'll take a quiz on lesson 6-1 to 6-4. And then we'll pick up again towards the end of the week with lesson 6-5 for the second half. So we're going to be taking notes from lesson 6-4, and we're going to be now reading English and writing algebraic expressions. So this is when we read English and translate. So today's date is going to be 2/4. Oops, that's a terrible 4. Sorry about that. 19. So, big part of what we're going to talk about in our notes today are words that tell us to add, subtract, multiply, divide, special words that change the order of what we write from what is written, and words that tell us to use parentheses. Okay? So, we're going to start with how to write an algebraic expression. So when I say algebraic expression, we learned from last week, algebraic means algebra, so there's a variable involved, and expression means it's like a math phrase that doesn't contain an equal sign. So how to write an algebraic expressions. Maybe I should get my tenses to match. How about that? That looks better. All right, so we've got 3 steps, excuse me. Step 1, we're going to read the phrase in English at least 2 times. Read the phrase in English at least 2 times. And we've talked about this before with word problems. First time we're just trying to get a gist of what's going on in the problem. And the second time we start picking it apart for all the stuff that we're looking for. Next, we're going to identify the unknown. Identify the unknown. So what is it that I cannot translate using words or operation symbols? Words, not words. Operation symbols, numbers. Okay, what is it that I can't translate that way? So the unknown, again, is not a number, because we know how to translate 12. We would write 12. Or an operation. Okay, it's some other value. So one of the things that we're going to work on is this notion of define the variable. Define means give a definition. The variable. So we get a couple of steps here. Okay, so first thing, we're going to choose a variable. And we can choose any letter. You know me, I've told you this before, I'm pretty ingrained by Mr. Cuneo, my 8th grade teacher, to go ahead and use X. And so much of what we do in math deals with X's and Y's, so it kind of makes sense. Sometimes I'll veer off that path and I'll pick a letter that represents the word or words that I'm representing with that variable. Sometimes kids just pick their first letter of their name, and that's the variable they choose every time. Just steer away from zeros, so no O's, no lowercase l's that looks like the number 1. Okay, those are just some ideas of things to avoid. Okay, so then you're going to explain in words, and I'll demonstrate all this for you. Explain in words what the variable represents. So what words from that phrase am I replacing with that variable? Okay. Now, when it comes to this definition, you want to be specific. Don't be general. Okay? And again, I'll demonstrate that as we get through it. Okay, now that we're all ready, We are prepped, and we are going to then translate the English into numbers, operations, and variables. Okay? Now, our notes altogether should be 2 pages long. The first page is going to be all about the words and how we translate them, and the second page is going to be the algebraic expressions. But because I have so much to do, I actually am going to go to the next screen to start with words that tell us add, subtract, multiply, or divide. Okay? Okay, so what we're going to do is talk about words that mean operations. Can you hear my dog lap up her water? Yep, I'm down in the kitchen because I'm baking bread. In fact, let's make that our special word, bread. Totally gotten into making artisan bread. Super simple. 4 ingredients, sometimes maybe 6 if I want to make it fancy. No kneading. Awesome. Probably make fresh bread 2-3 times a week. All right, so we're going to break this chart into addition words. So words or phrases that mean addition. Well, that's really long. We'll see if I need it that long. Subtraction. Multiplication. Oops, sorry. Multiplication, huh? I don't think so. And division. Okay, so what kind of words will you see for addition? Now, I'm going to be honest with you, this is not exhaustive. That means there's far more words that possibly could be used here. Also, a lot of words that we'll see are very similar to ones that we have. All right, so let's start with some obvious ones, plus. Now, I'm not going to write the super obvious ones like add. I think we know that means to add. So plus is a good one. Total is a good one. Though sometimes total means answer, so equals altogether. Sum, that's the answer to an addition problem. And then another one is increase. And then here comes a couple of special ones. I'm going to put some stars next to them, and then we'll talk about what do those stars mean afterwards. So we have more than, and then more than and all of its cousins. So things like greater than, taller than, older than, you name it. Anything that means growing, than, with the word than. And then the other one is added to. So again, I'm not going to tell you quite yet why I'm starring them and what makes them special, but we'll get to that. Okay, so those are words that mean to add. Let's talk about words that mean to subtract. Let's start with minus. Again, I'm not going to use the word subtract. Let's talk about, we don't have as many cool ones on this one. Here's an old-fashioned one, take away. We don't hear that one so much anymore. Diminished. That's kind of more old-fashioned, but I'm seeing it come back more and more. And then decrease, opposite to increase. Actually, let's do that next. Excuse me. Opposite of a sum, which is the answer to an addition problem, the answer to a subtraction problem is called a difference. So when we heard that word in English, that means to compare what you see that's different between these two, but in math it means to subtract them. And then the opposite of increase is a decrease. And then we do have some starred words. So I'm going to give it a little darker red on this one. And more than and less than is the subtraction version of that one. And then the opposite of added to is subtracted from. And again, there's way more terms than this that mean to subtract, but this is a good beginning. All right, when we get into multiplication and division, we don't have as many words, okay? So multiplication, times, that's probably one of the most common ones. Of, we've talked about that before when we were dealing with percent proportion. Product is the answer to a multiplication problem. And then we've got specific numbers, words like twice or double, and they do mean to multiply, but more than that, they mean to multiply by 2. And then we also have another one that our English friends will probably hear more often, and that's the word thrice. And that means to multiply by 3. Okay? So just some ideas there. And then last but not least, let's go to division. Let's see, divided by, yeah, that's pretty basic, right? Split into equal groups, that idea of equal groups. Each, so like in each group. What's in each group? Per. Okay, we've been talking about that one a lot. A ratio, which is a fancy way of saying a fraction, which is a fancy way of doing a division problem. The answer to a division problem is called a quotient. And then we do have one special one, and that's divided into. Okay, magically those lines have disappeared. It gave me a little bit of a moment to go ahead and drink some tea. Still not working. And so what I'm going to go now and talk about what's so significant about more than, added to, less than, subtracted from, divided into. Notice multiplication didn't have one of these kind of phrases. Well, what's interesting is that normally when I read, I just translate. But in the case of these starred phrases, they tell me that the order that I see things is opposite to the order that I'm going to write. So, for example, in English we say White House. In Spanish, you say La Blanca Casa. So that is, or hello, try that again, La Casa Blanca. And that means the house white, literally translated, but what we read it as is the White House. So in some languages, they actually put the noun in front of the adjective, whereas in English we put the adjective in front of the noun. So for us, these switcher phrases are doing that same sort of thing, and they're telling us the values that are in front of that switcher phrase and behind that switcher phrase are actually, when I translate it and write it out, I'm going to switch the order. So let's call them words that change order. And I'm going to call them switcher phrases. And they're going to be more than and all of its cousins. You know what? That looks like one big word. I get on your cases for doing that, and then I do it. Bad girl. That's an adding one. And all of its cousins, and we've got added to. That's addition. We have less than and all of his cousins. Smaller than, younger than, shorter than, exactly, all those sorts of things. Subtracted from. So it's not this single word, it's a phrase. So you're going to have these two words together. And then the last one was divided into. So we're really just trying to distinguish what came first and what came second, okay? Now, one other group of words that are kind of important, or it's actually phrases, are words that tell us to write parentheses. So, words that mean parentheses. Oops, spelled that wrong. Entheses. And these deal with the answers to an operation. So, for example, we have the sum of. What that tells me when I hear the words the sum of 5 and x, what I'm going to do is I'm going to have parentheses and I'm going to have a number. Now, the words that the values that they're telling me the sum of, they're going to be written, the first one in front of the plus and the second one after the plus. We have the difference of. So parentheses, subtraction, parentheses. And then we have a generic one, the quantity of. And I honestly, it'll have to give you another word that tells you what math is going on. The quantity of a number and added to 7. Something like that, okay? All right, what we're going to do on the next page is practice. So let's get to it. So directions are going to ask us to write. So remember, this page should already be titled. Write each phrase as an algebraic expression. Now, what this doesn't say, but it's going to expect you to do, is to also define your unknown. So there's going to be some words we won't know how to translate. So those leftover words are going to be the ones we're going to use a variable for. So what I'm going to do is mark up each of these as we go through, and we only have 3. So we have $10 less than the original price. So we've got some sort of money problem here. So one thing that we're going to do is look for things that I do know how to translate. So for example, numbers. That's easy. That's 10. Now, I'm going to put a little note over here. When we're writing our expressions, there's no labels. When we come to answers, that's where the labels show back up again. Okay? Let's see. Are there any phrases that mean an operation? And the answer is yes, less than. But less than is twofold. It tells us we're going to be subtracting, but it also tells us we're going to be swapping the order of what we see in front of the words less than. So I'm going to kind of put like a block here, and the words that come after less than. Now, let's take a moment and look at the words that come after less than. And it's the words the original price. And the reality is, I don't know what that means. That's our unknown. I can't turn that into a number or an operation. So that's the one that's going to be considered what we call the variable. So I'm going to pick a variable, and again, I'm going to choose x. And here's the definition. I write equals, and then I take those words, and I write it as a statement. The original price. Now, if I want to, I could actually add the label there so that when I get to the point where I could solve this, I know what my answer is going to have. So I'm going to go ahead and translate this. So remember how this is going to change. We're going to have a subtraction problem. The original price, which is x, is going to go in front, and the $10 is going to go behind. And that's my answer, x minus 10. But if I don't have the x equals the original price, then I kind of don't know what the problem is all about. All right, let's try another one. Another money one. $3 more than 4 times the cost of pretzel. Okay, so let's scan through here. Let's deal with numbers. Those are the easiest. 3, 4. All right, let's look for operations. More than. So that's going to be an adding, and it also is telling me anything that comes after the more than is going to go in front. Anything that comes in front of the more than is going to go in the back. So that's my switcher phrase. Now, 4 is not it. There's actually another operation there. There is times, which means to multiply. But what are we multiplying 4 by? The cost of a pretzel. So since I don't know how to change that into a number and operation, that's got to be my unknown. Okay, so I'm going to define my variable. X equals the cost of a pretzel. Now I'm going to tell you, if you guys just embrace what I'm trying to teach you here, it's going to make life down the line so much easier. All right, so here we go. 4 times the cost of a pretzel. Now remember, we talked about this in another set of notes. We can show multiplication with just a number connected to a variable. That means 4 times x. We've got plus, and then we have 3. And that's it. Now, I know I'm going to get asked this question 1,000,006 times. Do I have to write out the English? And the answer is no, you don't have to. If you can do that, that's fine. But sometimes it's helpful to have it written out. All right, last one. 12 times the number of feet. And I saved easiest for last. How about that? So let's find our numbers. I see a 12, and that's it. Let's look for operations. I see times. Ooh, sorry, I forgot to write 12 underneath that 12. Beak. And then, let's see. Times is multiply. And what are we multiplying by? The number of feet. Well, I don't know how else to say that, so that's going to be my unknown. So x equals the number of feet. Okay, so notice this time there's no switcher phrases. Awesome! So our answer is going to be 12 times x. And so how we're going to show that is just 12x. That's it. All right, have a great time, guys.